Hey everybody, welcome to Houdini Hangout. This is the 6th of February. Welcome to the stream tonight. So hopefully, if you were trying to watch last time, you're able to watch again tonight. Last Wednesday, I was having some network problems, things like that. And hey, Zach, how's it going, man? Glad to have you with us this evening. Had some issues with my internet, and so this is a little bit of a take two for talking. Hey, how's it going, man? I don't even know what I would call you there. KZ, how about that? Yeah, KZ. Welcome to the stream, KZ. Polymarvel. Hey, how's it going, man? Igor, nice to have you here. Thanks for joining. So the topic for this evening is going to be hello, render. Yeah, hey, the topic for today is going to be some USD. We're gonna be starting off pretty basic, just because I want to kind of make a little kind of a little set of videos, kind of a little series on USD and kind of getting us up and running. To have that kind of conversation. I know there was a lot of talk for, hey, Kevin, welcome to the stream. Glad to have you. There's a lot of talk when I did a poll of everybody on Discord was, USD and Solaris was a big topic that everybody wanted to hear about. Vex was one. We definitely tackled that already a little bit this year. Obviously, that will continue to be a part of the stream for sure. But so I'm kind of changing gears a little bit here, and we're gonna do some Solaris talk, USD specifically, but with obviously Solaris is USD. So, So this past weekend, I had the pleasure of being down in Texas at Texas A&M University doing some presentations. Got to meet some really cool people there. I also got to meet Mark Fancher, who does training and stuff, works for Already Been Chewed. Super awesome guy. He was really fun to get to chat with. Our background is pretty similar, so it was definitely I could definitely understand kind of where he was coming from. I think vice versa, both coming from like the more of the MoGraph world. So certainly a lot of fun getting to chat with him and just with all the students and everything like that. So if anybody watching was there, thanks for coming out and joining us while we were there. So this will be it's actually some of the stuff that I was talking about while I was there. That it won't be posted or anything online, so I figured why not share it with more people out there. I'm also in the midst of making a course that's going to be on it's going to be on our internal learning platform for side effects, but also is going to, I think, eventually be on the actual public website as well. So some of these things are things that are just on my mind and kind of I'm working through and stuff. And I've already done about 2.5 hours of intensive Solaris training on the internal kind of private instructor / studio stuff that we put out, but it definitely, there's no way I'll be able to cover that in the public course. So this will be kind of an aggregation of a lot of that stuff, and hopefully it'll get you feeling like you're up to speed a little bit with Solaris and with USD. So so that's kind of the topic for today. We're gonna start out super basic. I just want to make sure everybody's on the same page. Some people maybe have never touched Solaris or USD. Some people have done a lot with it. So there's, I'm sure, a lot of variation there as far as kind of where people are coming from. So I've talked about some of this stuff before, but I kind of want to just combine a few Synthize. Yes. Synthize is an awesome program. If you're not familiar with what KZ's talking about there, that is, Synthize is a camera solving software, and planar tracker, point tracker, camera solver, all sorts of different stuff. It's like, I think it's like the ugliest software I've ever seen in my life, but it also is like probably one of the most powerful, maybe besides Houdini. It can do so many crazy things. It looks like it was made like 100 years ago. But yeah, synthesize. Hey, Chester, I think is the name there. Nice to have you on the stream. Welcome. All right, cool. Well, let's dive in and we'll kind of talk through some of these different topics. As always, if you guys have any comments, yeah, I mean, I love Synthesize, man. I love it. That's the only software I would use when I was doing, tracking and stuff. But man, it is old looking. It's definitely feels dated, but you can do like everything tracking with it. So it's pretty awesome. Anyways, so as usual, like if you guys have any comments or thoughts, please drop them in chat. I'd love to hear from you guys while we're talking through these things. It's going to be kind of a more technical talk today, I feel like, but hopefully we'll be able to make some interesting looking things. I actually have a little HDA that I built from this kind of workshop that I was running, and I'm going to use that to kind of walk through this, and might even put it up for download afterwards. It was just something I made, so it's pretty basic. It's nothing crazy, but anyways, yeah. So please feel free to ask questions. There's no stupid questions. Everybody's going to be coming at this from vastly different competency levels, and some people that might be amazing in Houdini have never touched USD, and people that are sort of new to Houdini might have gotten into USD first and might be kind of further ahead. So, everybody's kind of on this interesting playing field right now when it comes to that topic. So, yeah, please feel free to drop comments in there. I'm certainly not the expert in this topic, but I'd love to hear from everybody. So let's jump in. Let's do some Houdini stuff. All right. So first of all, just disclaimer to start out the stream here. Like when you're working in Solaris, it's pretty much always advisable to get into some sort of desktop that's going to make sense for that. I mean, I'm starting with the Solaris, the basic Solaris desktop. You might have some other options that you might want to do. Sometimes when I'm doing layout and things like that, I'll kind of have a couple tall columns here just because the layout lop within Solaris, which we'll probably get to a little maybe in the next couple streams, that has like a ton of UI to it. So it's really nice to have a tall panel for that to sit in. Some other things don't need it, but this is a good starting place if we need to move things around. The other thing too is that Solaris and USD in general is just really data rich. There's a lot of stuff you want to inspect and get in there. You don't really end up using the geometry spreadsheet for that. You use your panels down here. So let's talk about kind of like what you're going to be seeing me do, why I'm clicking on these different things, just so we can all be kind of on a level playing field when it comes to all these different kind of panels and elements that we're going to be getting into. So the scene graph tree is down here. This is going to be a tree, like our hierarchy view. So that'll be where we're going to see a lot of things happening, kind of where our structure is going to be built. We can also drag and drop from this to parameter panes, which is really helpful. You can use that to select what geometry you're operating on. So that's something that I do a lot. There's like 2 or 3 main ways that you can select geometry within the Solaris tool set. So that's one of them. There's a couple other ones as well. Scene graph details is this section here. And, instead of just having a blank scene here, why don't I put down just a primitive node? And this is going to, oh, sorry, that's why, because I'm in the wrong geometry here. My bad. Let's go to the stage. So I'm just right clicking there, going into stage. Now we're actually in Solaris. I was just in the wrong spot there. It's like, why is that not coming up? That's weird. Should be the first in the list. So primitive. So this is like a super basic node, and it's a way that you can make primitives. Everything that's going to show up in our scene graph tree, each line of it is a separate primitive. It's just the name, just the way that it's named. So something to keep in mind. But like, so say I wanted to make like a path or something like in here. And so I'm going to populate my scene graph tree a little bit here. So I'm going to do like, I'm just going to type in a path here, forest slash tree slash trunk slash branch slash leaf, just like that. So Okay, so we've got this all set up here. And what this is going to do is make a hierarchy for us here. So now we've got some stuff to look at and kind of inspect and see what's going on here. So anyway, so each of these we can select, right? We can select each of these different primitives here. We can see the scene graph details here. So these are going to be some things that are maybe computed for us already, like transforms and things like that, what the visibility is, things of that nature. And then metadata is going to live in here as well. This actually might seem like a really deep thing to be inspecting, but it actually is really helpful when you start getting into things like variance and things of that nature. So that's really important. So this is kind of our pseudo geometry spreadsheet you could think of in Solaris. So that's a good thing to kind of keep in mind while you're working there. And then this scene graph layers is one that I actually hadn't heard a lot about before I kind of started diving into some of these deeper topics. So it is a little bit of a, maybe a more technical look, but basically what this is showing you is the current layers that are existing in your scene. When I say layers, USD kind of refers to files on disk as layers. So that's usually kind of how you're looking at when you hear the word layer. So here you can see that this is a lop layer. We're looking at this primitive right here is the only thing kind of in this root layer, so it's named it that. And this actually tells you where your different layers are being saved, in your scene, like where they're getting saved out to. We're not going to do a ton of that in this moment because that kind of gets into some other, you might get into some other things a little bit further down the line there. But this is a way to see kind of what files are being loaded into your stage and what you're working in here. So you can see here's stage. That's kind of what the context is called. So that's kind of the main pieces to what we're going to be looking at here. You're going to see me kind of slide these around a lot because there's so much information that it can be really helpful to kind of slide that around and get some more room in there to work because it's just a lot of information, a lot of things to jump into there. So kind of interesting, like we have this primitive node here and you can see that it's creating stuff, but obviously nothing is in the viewport here, right? So there's nothing in the viewport. So let's just change that up a little bit here. It's really interesting because primitives can be just kind of like, you can have them as like kind of these empty placeholders, or you could have them be things that are actually defined, right? So we can look here, and if we look under primitive type, we can see all of these different kind of definitions that we can give these primitives. So for example, we could do a cube, right? That's going to drop a cube in there. And you'll see that this is only going to drop a cube in for the absolute leaf of this hierarchy. When you get to this last primitive in your hierarchy, that's the leaf primitive. So the leaf primitive, and I'm going to name them leaf just to make sense of that, to tie that idea together, is going to be the one that gets created as a cube. The rest are just going to be these little X-form, little transform primitives. We can also change, this is a very common thing to do. You might want to have these be scope primitives. That just means you can't move them, right? They're more or less like a null object in a hierarchy. You can't really move them. You can't really do anything with them. They're just there for organization. So something to keep in mind there, but we can leave them as X forms. That's fine. There's a few other things here that we're not going to get too far into. These are maybe a little bit more in depth, a little bit more detail oriented. But what we're going to do with this node is we could set up like a hierarchy, right? If you knew you were going to build a scene, right, and you were going to maybe lay out a whole environment, you could actually build a hierarchy here of maybe the different elements that you're going to make. Now, in this case, you're not going to specify maybe every single leaf. But maybe what you could do, I'll keep the leaf there just to keep the idea of what the leaf primitives are visible. But let's just change this up a little bit. We'll say branch 1, leaf 1. We'll just copy this a few times. So you can just kind of copy this, and we'll say leaf 2, and then, we'll copy this like that, and we'll say leaf 3. And then maybe what we'll do here is we'll just take a whole bunch of these, paste them like this. Yep, that's a lot of information there. And instead of having these be branch 1, we'll do branch 2 like this. And then as well, let's do this, and we'll just say, we'll just put a couple leaves right on the trunk, for example. So we'll just say like this, leaf 1, and then copy this, paste it one more time, do it like that. Okay, so now we can see that there are a few different, hierarchies going on here, right? And I think you can imagine what's going on here. You can understand what's happening more or less, but I'll just make that a little bigger in case you need to see it. But we've basically started building a hierarchy here, right? And so we've got these cubes at the very bottom of this hierarchy here. So for example, if I wanted to transform just one of these leaves here, what I could do is I could do a transform, right? And I could, so right here we can see that this is kind of how we define our primitives that we're moving in Solaris. So I'm just going to grab, I don't know, leaf 2, drop it up in here. We can just move that around, right? So now we've moved one of those leaves out of just that origin spot, and it's up here, right? So this is just, pretty straightforward stuff, pretty simple. We should be able to see that these transforms have changed. In fact, as I move these around, those will get recomputed, right? So our transforms are changing here for leaf 2. But this is a contrived example. It's not super interesting, but what you might do is something like set up a bunch of hierarchy for a shot, right? You might have a bunch of buildings, you could have a bunch of trees, you could have a bunch of anything. You could start building your hierarchy kind of just as like a sketch, for what you're going to fill in later. So this primitive node is a way to kind of start to build your hierarchy, but it's also obviously a way to kind of visualize what's happening here as well. So this can all be done programmatically as well. You could, use expressions and things like that to bring in strings to build those paths. So this idea of a path is kind of key to working in USD, right? Because each primitive in your scene is going to have its own path, right? It's going to have its own, they call it namespace in USD terminology, but it really is just like a path like you would have in regular SOPs, right? A way to kind of identify where something lives kind of in its hierarchy. So that's the idea of the primitive node there, setting up some kind of base hierarchies. And as you can tell here, you could do a whole bunch of different stuff. You could set up a bunch of cameras if you wanted to, or lights or whatever. You can do all sorts of different things here. So just something to keep in mind, that you can kind of set up a bunch of different hierarchies with this primitive node, kind of to begin out, to kind of start out where you're going to go with your scene. Another thing to keep in mind too is that there's some really weird types of primitives. One of them that's really interesting is that there's render settings here. So like you can actually set up render settings, as a primitive. So it like lives in your scene like that. And the reason for this is that by definition, USD is a scene description language, right? So it's actually going to be explaining to the renderer what the scene is that you're putting in. Just like in Arnold, you would have a .ass file. In RenderMan, you'd have like an RIB file. This is one of those, right? And it's kind of ubiquitous between all of the different renderers that use USD. So that's why you could have something like a render, render settings. You could have shaders. You could have all these different things as primitives. They all just kind of live in your scene graph tree as primitives. So it allows you to be able to call those render settings. You could have them even for separate renders if you wanted to, I guess, have some render settings set in there. So cool. So that's kind of just the primitive node. This is just a way to kind of start to see how we work in Solaris and with USD in Houdini. But let's do something maybe a little bit more interesting to kind of actually build some geometry up, right? So there's a couple different ways that you can bring geometry into Solaris or into the USD environment here. And one of those is with a SOP create. So this is just a really handy node because it's a SOP network inside of a LOP node, right? So this is you dive inside here and we actually have a SOP network inside of here. And so what we can do is start to work with some geometry here, right? So we could, I'm just going to go to the trusty old pig head, and we're going to use some more interesting stuff in a little bit. But so we've got our pig here. We could keep our grid on, whatever. So let's look here. I'm actually going to put the geometry spreadsheet down here. I'm going to do an inspector and do a geometry spreadsheet just so we can at least see sort of what's going on here. We won't be looking at the scene graph tree for a second here, but we're just going to make some geometry. So trying to remember what is missing here. I think normals are missing. Yep, normals. So we'll add some normals onto here. I'll just do them as point normals. Should be fine. We've got UVs. We've got shot material path. I'm actually going to well, I'll leave the groups for now. There's 4 primitive groups on here. I don't really want those. I wouldn't probably want those if I was going to be using this for something, but this will be fine. No problem. Actually, I'm just going to set this back to vertices. Doesn't really matter. Okay, cool. And then we'll just put an output here just to make sure that that geometry is coming out for sure, no matter where the view flag is, right? So now we come up here and we have our pig being viewed. Now you'll notice that we don't have a shader on it. That is because from a SOP create node, you could possibly autofill some materials, and there we go. That's going to actually load in those materials for us. This is actually a newer feature, I think, of the SOP create node. So you can autofill your materials like that, and that will allow you to actually have the shaders come through as well. So let's look at the scene graph tree here and kind of see what's happening here. Okay, so we've got our SOP create, we've got a mesh, it looks like here. We've got some really weird shot material path things going on here. We've got some shaders. You can see these are materials here. So now we're looking at more or less the same pig geometry that we had before. But why is it kind of coming in this way, and what are we, what are we getting out of this? So what we have that's a little different in USD and in Solaris is the idea of kind of this import step, right? Where we're bringing it in from SOPs and we have to transfer it into the USD kind of framework. And so there's a bunch of different settings here. So I'm just going to move this down because we know it's just a SOP create node. There's a bunch of different things that we can set up as far as how this geometry is going to be brought in. So there's one thing, like here you can see partition attributes. This is set to shot material path. So that's something that we can play with here for sure. There's a few other things, like path attributes is a really helpful one. What to do with packed USD primitives, that's some options here. I'm not going to go through all of these, but this is where you would go to find kind of how, like if something's coming in a way that you're not expecting into your Solaris, kind of scene. In your scene graph tree, it's showing up in a weird way. This is where you would go. You'd find this on the node. It's different nodes have this. There's the SOP create node. There is also a SOP import, which you could bring from SOPs itself from your object level. You could also create a SOP network right here and then SOP import it. There's a few different ways you could go about doing this, but so some of these nodes here will have different. This same import from SOPs dialog. This is going to be kind of a common dialogue between a lot of objects that are bringing geometry into Solaris. So, all right. So let's first try to fix this issue here with these long, weird names, and we'll maybe talk about why exactly that's happening. So, okay, let's move this around so we can kind of see what's going on. So again, like I said, there's this partition attribute. So what it's doing is it's creating these geometry subsets based on our shot material path attribute. So that's what's happening here. It's partitioning our geometry based on the material path, right? So this is a way that we can add multiple shaders onto our one mesh geometry. So these are each subsets of this mesh geometry right here. So we can see this is our mesh. These are our subsets, right? And here you can see there are a few things, right? So these subsets have indices, and it's telling you which index of that, these incoming faces are going to be inside of this, right? So each of these are going to have different indices that are going to be within these subsets. So so this one here is in the 2600s. This one has 1, 8, 9, blah, blah, blah. This one has 0, 2, 3, and all these other ones. So they're ways that we can take chunks of our geometry. We can't transform these. We couldn't take this and move it around. There is no transform setup in here, but we can bind materials to it, and that allows us to take something like the eyes material here and bind it to this. So it's a really helpful thing for adding shaders to your geometry. And really, these are probably closest in SOPs to groups. So these are really similar to the way that you would work with groups in regular SOPs. All right, so let's clean this up. So one thing to notice here is that there's this parameter below. It says prefix subsets with attribute name. So this is actually, yeah. Yes, it is possible to rename that. Yes, for sure. I'll show you that in a second. We're gonna do that. We're gonna do that in a second. So we're actually gonna set not only the name but the hierarchies of them as well. So yeah, you can set both of those. It's actually pretty straightforward. It's with a name, with the name attribute. But we'll get there in a second. Is there any way to access multiple materials coming from a USD file? Yeah, for sure. Yeah. Yeah, you can. Actually, I'm misunderstanding. Like creating a material network instead of editing one by one. I'd have to see if you have an example of that or something. You could always drop that in the Discord server, Chester. I'm not exactly sure what specific use case you're talking about there, but there certainly are ways to programmatically assign materials based on, in this case, like where those geometry subsets are. You can actually have it look at those and pull in shaders based on that. So there's some ways that you can do things programmatically in Solaris, but I'm not 100% sure what the question is exactly asking. So yeah, I would love to know more about that so we could have a better conversation about that, but it might be possible. In fact, I'm sure there's a possibility to do whatever you're asking there. But so anyways, with this little grayed out thing right here, the thing to know is that is the default, right? So it is still prefixing subsets with attribute name, even though this isn't checked. So when I check this, it gives me access to it. But these are, so like here, translate UV attribute to ST, that is happening right now. In fact, we'll look at that in 1 second. But so what I'm going to do here is I'm going to uncheck this. And so now, unfortunately, this shot material path, what it's doing here is it's adding this shot material path underscore blah, blah, blah. So here we're prefixing subsets with the attribute name. So in this case, it'll take it out of this, kind of having the shot material path at the very beginning of it and try to shorten it a little bit. There is actually better ways to clean that up as far as like making separate groups and bringing them in. So what you could do as well, instead of partitioning it this way, you could partition it based on the group type. And that is, sorry, let me just think about where that is. But anyways, for right now, we're just going to leave it like this because we're actually going to get rid of these in a second anyways. But that's a way that you can make sure that the attribute name isn't there. Now, unfortunately, the rest of this shot material path is all of the /stage/SOP create /SOPnet /create. So that's what it's reading in here. And that's why it's got this huge, long mess of a name. So anyways, that is what's going on there. And that's, that's something that you can try to clean up a little bit. The other thing that we can do here is instead of subsetting based on the shot material path, you could subset based on the groups. So you can see all the groups here, right? And so what we could do here is we could just put a star in here, and this will give us all of those geometry subsets based on groups. So what we could do then instead of assigning these materials and things like that, we could take this geometry path here. We could get rid of these. I'm just control middle clicking those. We should be able to, oh, right, because it's creating it here. So what we should be able to do is say, that's eyes. So can I do this? Yep, there we go. So now I should be able to drop these in here and do it that way. So let's see here. So we should be able to say, this is just the pig. So we're going to say pig face. Probably can do, I see. So let's just do this, face, neck, throat, like that. We'll control click all of those, drop them in here. There we go. I'm not sure which one this is assigned to, pig, no, UV. Maybe that's the throat, actually. Now that I'm thinking of that, let's see. I don't remember off the top of my head. But you can see this is how this kind of this workflow goes, right? You can select from your scene graph down there and drag them into these individual geometry paths. And this is how this is getting assigned. It's a little bit confusing here because it's got some strings in it, right? But basically it's saying that we're taking this material here, right? So pig, no, UV, pig, and eyes. We're setting this as the material path, and then we're assigning it to these like mesh 0, pig eyes, things like that. So now we have this a little bit cleaner. It's still showing up the way we kind of want it to. And yeah, so it's a little bit cleaner. So let's now, the other thing too to keep in mind here is that if you control click and look at several of these, you can actually have multiple primitives be selected in here. So you can look at pig face and look at the indices for that. There they all are. And then here's the pig throat with its indices. So you can select multiple and kind of inspect those in more detail. All right, so let's jump back in here. Make this a little bit bigger. So what we should be able to do, I'm going to go back to my geometry spreadsheet here, go to this. We should be able to change the name of this. So let's put a name down, right? And there's our name. Let's just set this as pig head geo, like so. And now we should have pig head geo, and these have all been changed. Now, another thing interestingly here that you can do is we're inside the SOPnet over here, but this scene graph tree will actually evaluate if you're looking at it. So here you can see that has been changed, and it'll be live too. So I could just say, give it a couple extra letters. There you go. So, this is a way, so with path, you can change, or I'm sorry, with name, you can change the name of the specific primitive that's being created. So in this case, pig head test, all of the primitives that are coming in have that name, so they all go into a mesh with that name. So that is how you would rename that, Igor. So, yeah, it's super easy. So now here's the next really fun part about working with these, is that it's actually really, really simple to bring in multiple hierarchies here too. So with a lot of assets in USD, you want to have separate proxy render geometry, maybe even sim proxy geometry to be able to have different elements used in your scene, right? So you might have a proxy and then you go into render and karma or whatever, redshift, whatever you're using, and it'll switch from the viewport proxy to the render primitive that's going to use and actually render the full resolution geometry. In order to do that, you need to set up some hierarchy, and it can be a little bit, if you're looking at this, you're like, okay, so I understand that setting the name here, we can say like primitive name, right? That's going to set this primitive's name, but how would we do it? Have like multiple streams of geometry all coming in and being in different, going into different primitive hierarchy. So that is actually pretty straightforward. So let's do this. I'm going to do kind of an example that I've done a few times in other places. So you may have seen this online somewhere if I've done it before. But so we're just going to subdivide this pig head right here, and I'm actually going to go back to our geometry spreadsheet here. So this isn't, I'm going to hide the other geometry. So this hopefully won't be updating right now in, actually, you know what? That's going to make it update. Whatever. It's not a big deal. So we're going to subdivide it. This is going to be like a render geometry, right? So I'm going to use another name SOP. I just think it's a pretty clean way to make a string attribute and name it and type in a string real quick. So let's set up a path here. So what we're going to do is let's set up our path to be, so we're going to call this, So it's going to be, okay, let's think about this here. So I'm going to say pig head asset, like that. All right, so it's going to be our pig head asset. Then in here, we're going to, instead of calling this pig head test, I'm going to call that pig head, I'll just say pig geo, like so. So now we've got pig geo. And here, what we're going to do is we're going to use this same hierarchy, right? So we're going to say / pig head asset, then / pig geo. And obviously you could do this through expressions and things like that if you wanted to. And so that's going to be kind of our hierarchy right now, right? But what if we wanted to add another primitive, maybe a couple primitives in here? Let's set this to be, we'll do geo, and then we'll do render like this. Okay. And now this isn't actually coming out yet, so that is not going to update. But if we took this and put it down here, we should see that that will now update. So now we have geo, render, and pig geo in there. Okay, so that's our high resolution, geometry. Then what we could do is we could do something maybe lower resolution, right? So what we could do is we could do a poly reduce, and this is really common for even some of the tools in Solaris and LOPs to do a poly reduce to get a proxy geometry or whatever. So I'm just going to do, I think 25%. Yeah, it should be fine. So we'll do a poly reduce. And then what I'm going to do is just copy this over and we'll say render path. And then this is going to be proxy path, like so. Okay, so now we have these two streams. So now if we just shift click these together, merge them and drop them down, well, I didn't update the path. That's why. So we want this to be, instead of render, we want this to be proxy. And now we have a proxy pig geo and a render pig geo here. So these two different streams kind of data through our geometry, even though they're on top of each other, are going to, you can see that they're both loaded in now. We have our high resolution kind of quad mesh, and then we have our lower resolution poly mesh or triangle mesh here. So that's like our proxy, right? And then what we might do here is if we wanted to use a sim proxy, which is another thing that's used by, collision detection and things like that, we would do a shrink wrap is an easy one to do just to get kind of the shape of it, right? Kind of the, the shape like that. And then we could do a remesh, drop this down and just have a triangulated mesh like that, something simple. And then instead of that, this is going to be sim proxy path. And this actually wouldn't sit under geo. It would sit at sim proxy like this. And we'll merge that in here as well. And so that is more or less the way that this would work. And we also don't have the groups in that, but that's fine because for the sim proxy, that's yeah, of course. Can you try doing the same thing on? So what Poly Marvels, who's Igor, is asking about is can you try to do the same thing at object level and then import with a scene import all? I wonder, would you get the same results in the scene graph? That's a good question. I don't know the answer to that, so let's give it a shot. So we'll copy this. Let's just copy our whole tree here. I'm going to go up to the, there we go, object. We're going to go up to here. We'll just say, I don't know, whatever. It's weird that I had that there already, but anyways, so I paste that all in. Great. There's our output. So our pig geo is there. All right, so let's go back into the stage. So I'm just going to leave this here. We're going to actually just set up another node here to start with. So we'll do a scene import. So this is a way to basically bring everything in from your scene into Solaris and into USD. So it'll bring all sorts of different things in here. So like here you can see that it is going to be bringing in your the shaders right here. Here's our pig geo. Those are coming in just the way we had it there. Then we have object shopnet like so. So there's some interesting things going on here that are a little bit odd. And really the biggest difference between what just happened here is this stage and this object here. So what I'm first going to do is I'm going to change, let me just see here if this does anything. Yeah, so the one thing that's different here is that this is trying to make a component called PigGeo, because that's the asset that the node that I'm bringing in from the scene import all. And let me just see here. So this should turn off importing objects. Yep. So I could probably flatten the hierarchy. Just trying to see if there's any of these switches here that are going to help me there. So what I might be able to do is say object/piggeo could be my root. No, okay. So yeah, it's not going to, you have to have that slash after it there. So it's going to be a little bit different there because it's going to be in this piggeo component, but below there, it's going to be more or less correct. And if you changed your path for that you wrote in that scene out in the object level, you could possibly change that a little bit. So the real mess that's happening here is with the shaders, right? Because these are all just super deep in these different networks. So what we're going to do is I'm going to say flatten hierarchy here first of all. And then the other thing that we can do here is we can change this to look at, different shaders and things like that. So let's do this. We're going to import materials, but instead of a destination path like this, what we can do is we could pull this in here, right? Pighead asset, and then we could do / like MTL like that. And if we hit enter, so now that's going to put that into this material structure here. So unfortunately, because the pig is a test geometry, I think it's wanting to import that twice. So let me just see if any of these will see, because there's two versions of them. No. Just trying to think if there's something else here. So a lot of these there's a ton of different, settings and stuff like this here. So there may be one that I could possibly do here. So I'm just going to look at all of these, make sure I'm not missing something. Okay. So let's go back to the object level and just double check to make sure that I didn't do something stupid there that's causing that to have multiple materials set. I think it's just because the shaders are inside of here. That's my guess as to why because it's a test geometry and it has everything inside of there. So I think that's why you're running into that like doubled up. But for the most part, it will respect everything else that's coming in. So with the scene import all, it's a little bit more of just like an automated kind of heavy-handed, like just do your best and get it in there. Whereas if you look more specifically at the SOP create node, you have a little bit more control there. Things aren't going to just kind of randomly come around wherever they think they should go. It's a little bit more specified as far as like, hey, this is specifically where I want this to go. You could also turn off your materials here if you wanted to, and just bring in materials in the next section. So you could actually turn off the imported materials, and then it's going to look really similar. And I think there's actually a scene import materials. Not to say that that's going to really be all that different, but you could always split those out a little bit like that if you wanted to. So yeah, no problem. Yeah, of course. Happy to take a look at that. It's a great question too, because there are multiple ways, and this is kind of the more, if you've built everything in SOPs and you want to bring it in, that's more of the idea with that one versus this being like one at a time. So anyways, okay, so we've got this pig head asset here that we're working with, right? And we have these different streams here, but I didn't really exactly explain why we would do it that way, right? It's not maybe super clear as to why you would want to set it up that way. The reason is because this is kind of the I'll just slide this up a little bit here. This is sort of the recommended hierarchy for working with an asset in USD, right? And so when we're dealing with this here, this is not set up correctly yet. There's some really fine detail that needs to be set up on these primitives. Things like their kind, the purpose. So purpose is actually means will it show up at render time, or will it be a proxy, or is it some sort of sim proxy? So the purpose is just set to default on all these, which isn't correct. There's also a thing called proxy path, which will make sure that the proxy of these are set up properly as render geometry and its associated proxy. And then we can also do things like variants in here as well. So I'm just clicking on this little gear icon, and that gives me those options. Another thing too, in a lot of these is these little question marks, like these little like speech bubbles almost, have information in them to kind of show you what these different colors in here will mean. So when you see these different colors, like for example on this, we can see that there are default values for these. There's a fallback value. There's also relationships. So like in here, when I go to pig eyes, oh, those aren't assigned right now. My bad. Right, because I changed the name of them. So instead of it being mesh 0, it is now pig 0. So let's just do this here real quick. Like that. And the pig maybe be face and neck. There we go. We have this sim proxy geometry that's over top of it, so we can't really see that exactly. But anyways, when you look at this material binding here, you can see that that's a relationship. So there's a lot of different things happening in these scene graph trees and the details views and stuff like that. So this can help you understand what is happening with those colors there. Just a lot of information. And this viewer here is really based on the default USD view plugin that Pixar created. So this is kind of has some legacy built in from that as well. So we're always, I think SideFX is always kind of trying to make this a little bit more user-friendly and cleaner, and so this is always kind of can, I'm sure, be changing over time, but it certainly has a lot of information to be gleaned from it. So cool. So the thing that we want to do is set this geometry up to be kind of as easy as possible to get all of these different elements set the way we want them to. We could go through and add a bunch of nodes and things in here, like we can do these configure primitives, and we could come in here and say, for example, like if we didn't want to see that sim proxy anymore, we could grab this sim proxy primitive here. We could set its no, not its type, sorry, its purpose to be guide, and we could say its visibility is invisible. And so now that's an invisible piece of geometry there. Now we can still see the proxy and the render geometry, but our sim proxy is now invisible. We can see that these eyes here, it might be a little hard to see, just they're tiny icons, but these eyes are now kind of closed. You can also always tweak these, tick these visibilities on and off, and also change the activity of the if the primitives are active in the viewport here. So those are ways to kind of tweak your scene a little bit there as well. But we can see that these are set to guide, don't have a proxy path or anything. So we could go through and put a bunch of these, configure primitives down. We could just keep going through this, like, okay, we want to set up, this is our proxy geometry here. So we'll set, actually, no, we're going to set, we'll set this as proxy. So we'll drop that up there. Its purpose is going to be proxy. And then maybe we'd want to do another one here. And set this to be the render geometry. So we'll set this to be render, say render there, and then set its proxy primitive as that, right? Like that. So the only bad thing here is that we can get some really kind of strange little viewport bugs, but now we should be good. If we reset the viewport there, I always recommend having labs installed because it can help reset the viewport. And so we can see here we've got our preview geometry. I'm just going to do smooth wire shaded. Should see that. Okay. And then if we go to final render, there's our final render geometry. Now I don't have the shader assigned to it, but you can see that these are now, we're starting to build up this asset to work in a way that we want it to, right? If we were to, I'll just leave it white just to show the example. But if we were to be viewing the preview state here under these little glasses here, we're in the preview purpose that we're viewing, and we wanted to go over and pull down here and go to karma, right? It's going to render it as white because the render geometry is white. So when we come back to Houdini GL, we'll see that this is has the shaders applied and everything like that. So what we're seeing here is really this kind of separation of having proxy geometry, render geometry, a sim proxy that's invisible that we can't actually even see, but it's in the scene here still. So these are all things that we want to set up, but obviously doing that every single time you import something is a bit of a pain and probably isn't the best use of your time to do something like this. So we've actually, SideFX created the component builder workflow to be able to more quickly get to this exact setup. In fact, these individual primitives shouldn't be X-forms. They should be scopes. And so there's another thing that we should have to go through and fix. And so here, I would have to, oh, that's right. I can't even set that here. I would have to have created those ahead of time and done a whole bunch of different things. So it's kind of there. It's not the simplest thing in the world to just spit out, a nicely hierarchical model and everything. So what I'm going to do is I'm going to take this and I'm just going to make sure I've got this copied again. We'll do this. We'll copy this. And instead of using this, let's do component builder. You may have seen this before, but I'm going to try to talk through this in pretty good depth, unless you've seen Chris Rydalch's video, which he created these nodes, so he knows this way better than I could ever know it. But if you haven't worked with this before, this is a really great way of being able to work with geometry and shaders and things like that in Solaris and creating really good USD assets. So let's now jump inside this component geometry, and I'm going to paste all of those nodes. And if we look here, I'm actually going to get rid of these and this. We could leave the primitive name. That's not going to be a problem. But let's just leave these three streams of geometry kind of the way they are. And if we look here, we can see that there are three different outputs. One is going to be your render. It says default if you're not sure what you want. So this is the default, right? This is the low resolution proxy, and this is the sim proxy. If you only had one thing and just connected this, that's going to be fine. It's going to give you that as your geometry, right? So now we have this pig head. If we jump back inside though, and we want to connect everything, we can do this, right? And we can set our poly reduce here. We've got our sim proxy geometry coming in here, and we have our subdivision kind of high resolution going there. So now when we jump back up and we look at this, we're going to see it just says asset up at the top here, but we don't have to worry too much about that. We can see that this now has the geometry here, the proxy, render. These are all set for us. And what we can do now is use the same things that we were using before. So we could set it to preview, we could set it to final render. There's our final render geometry. A lot of interesting things that you can do here already. The one thing that doesn't come in this way is going to be the shaders. So we're not actually going to be shading on this component geometry node because this is really just dealing with the geometry. If you wanted to bring your shaders in, you could just literally copy them into here, right? So just for example, let me go in here, and I'm just going to allow the editing of these contents. I'm just going to grab these from in here and just copy them. All right, and we'll just drop those in this material library here. It should work just fine. Cool. Okay, so now we've got our shaders here. So what's happening here, this is creating kind of a similar hierarchy to what we had before, just with the name asset up at the top, because it's going to rename it at the end with whatever name we want to name it. So this is just a kind of a generic look for how this is going to be structured. You can see here our names came through. It still says pig geometry. Now the sim proxy didn't have that pig geometry name on it, so it just says shape. So it's fine. But the other thing we want to do here is we could partition attributes. So here we could partition by attributes, or we could subset by groups. So that's probably the better thing to do. So we'll subset it by the groups. We'll just put star in there, and that's going to set all of these groups for us, these geometry subsets. You can see here our proxies are set, our purposes are set. The kind for the top is set to a component because that is what it should be. Basically, a component is something that you would author on disk, right? So that's like your base, model asset in USD is usually called a component. That's like that's the smallest thing you would basically author to a USD file as a component. So we're going to author this to disk. So, all right, so we've got our component geometry here. We've got our material library. And if we look at this, we can see that this also has that same kind of top level asset primitive. Then it has material scope, and then has all these shaders inside of it. And so the reason that this is can be a really nice way of working is because you could get your geometry from one stream, you could get shaders from another, and then when we're combining them together, we can do a whole bunch of stuff to make variations on that. And we'll kind of keep talking about this a little bit throughout this chat tonight, but I have a little HDA that I created, and I'll show how that kind of works and how we can use that to create some really nice different variations and be able to instance those really quickly. So we have this component geometry, we have the material library, and then here in this component material is where they get kind of combined and assigned. So you can see here's material assignments. Right now, and by default, what this would do is if you had, I'm just going to make another material library just so we don't have that for right now, but let's just do this. Material library, and let's just say we made principled shader, just because that's kind of a basic one. And let's just say I made a gold one. What this would do, at least what it should do. What's it yelling at me about here? Oh, right. So this material library is kind of special because it's actually set up with this as its material path prefix. So this is all we need to have up here. So instead of being materials, we're just going to set it like that. Now it should find it. There we go. Okay, that makes more sense. I was like, why is that not working? So we have our material library, and it's going to just automatically assign that material, whatever the first material it finds, onto the geometry. All done. Principled shader assigned. We get down here, and this could just be called pig head asset. It's going to take the name of that, turn it into the component name, and save it to disk as that. It's got a ton of really nice stuff here built in, and we'll talk in a second about how this writes to disk, which is also really, really good and really helpful for a bunch of different reasons. So, all right, so we've got this, but let's actually assign it the right shaders and colors and all that stuff. So let's just take this out, put that in. And so now we can just do our assignments here. So I'm going to hit Control and hit this arrow, and that's going to allow me to pull up this little select primitives dialog. This is the second kind of way that you could set this up, right? So, so for example, we could just get render and proxy. We could grab the pig eyes from both of them. Oops, sorry, I could do it like that and say, okay, there we go. And then here we can grab the eyes, apply okay, cool. So then we're just gonna do three different assignments. So what I'm going to do here is I'm actually going to say face neck. So I just control click all of those, drop those into here. Those are the primitives we're going to go from. And then we're going to assign, I'll just control click. We'll say pig apply as such. That's strange. Let me just double check that that's working. Well, let me just keep going here for a second. See if I don't mess this up. Apply, okay. Let me just see if I need to like update the shaders. Huh. That is really strange. I'm not sure why that's not working. I can see the throat in there, but the skin outside is not working. Interesting. What about that? What if I do that? Oh. Well, cool. I'm going to have to look into that. Sorry about that. Time to save. Yeah, you read my mind, my friend. Hey, Matt, how's it going? Okay, that's interesting. Yes, perfect timing. Yeah, I don't know why that's not showing up. That is really odd. Move your display flag down to the output node. Hi. Yeah, I don't think that's actually the issue. It's for some reason it's not. Not sure about that. Not sure why that's not working. I mean, it's not the end of the world. I'm not really overly worried about it, but let me just try one of them. It's like the shaders aren't coming through properly. Oh, I bet you I know what it is. It's because I know what it is. It's because these textures are OpDef textures. That's why. It doesn't like those because so I ran into this problem just the other day. So USD doesn't. Yeah, so this is the issue, is that I copied those out of the HDA, and USD can't figure out where to get these from because here I'll save it out and I'll show you why that doesn't work. I forgot about that. So okay, so this is the really nice thing because this is going to make a lot of really cool files for us. So we're going to save that. I'm going to open up my. Yes, exactly. Right. Yes. So yeah, if you're just making a standard Material X and all that kind of stuff, it should be just fine. So I ran into this problem the other day, and it was certainly, I was super annoyed at first, and I'll show you what is happening here. So so what happens with this component builder here is that, sorry, let me just get to where I saved my files here. So it makes a USD folder for us, makes an asset folder, and then here's our pighead asset. And there's all these different USD files here. This top level USD file we can actually read because this is a USD A file. Let's see here. Just going to, let's see, can I make these? There we go. All right, so manage trust, should be able to read that. There we go. Okay, So what's going on here is that this is kind of our base level pig head, and it's actually loading in this payload.usdc. That's what it's loading in. And so what that means is that this pig head asset is loading our payload in. The payload is loading in the geometry and the material. So their geometry is saved separately, our materials are saved separately, and then those go into a payload file. The payload goes into the pig head asset. The reason that that payload exists there is really cool. It actually allows us to be able to unload this object in the viewport. So if we unload our viewport, we can still see this object here, and we can see our bounds and everything like that. But we still know things like, what variant is set on it, obviously the bounds here, and some other properties that we can bring up to kind of the surface of our primitives, to our top level primitive. So in this case, if I was to do something like duplicate, just add a bunch of copies of this here, right? So we'll do 20, and I'll just translate them a little bit, right? Oops, probably too much. So now we've got a bunch of, copied pig heads here, and you could go kind of crazy with this, right? You could do 200 or whatever and have a whole bunch of them in here. And so really we're not going to get any viewport hits from these because they're unloaded in the viewport. If we load them back in, it'll probably take a second for it to read them all and all that stuff. It's going to be a little slower in the viewport, not by much, obviously, but, we could do 400, probably be even more, a little slower. Not by a crazy amount, but obviously you can see that there's going to be some viewport hits with loading all these into the scene. But if we use this little mask right here and unload our payloads in the viewport, now we can have tons of viewport speed. And you could see that this would be helpful if you're working on a huge city, a forest, something like that, where you're making these assets, you're creating them the proper way where they're inside of that payload file that allows it to be unloaded. And then you could load or unload certain parts of your scene kind of as you would want to. You don't have to unload everything. You can use these nodes. Like, for example, you could unload all your payloads. Then you can create this configure stage node. And what this will do is I can actually set this back here. And then this configure stage is set to not load any primitives. And now they're all unloaded, and then you could change which ones are loading and unloading in your scene. So there's a couple other ways you can do this as well, but it's just something to keep in mind that this is one of the kind of strengths of using USD, where you can have these huge scenes. Not everything's loaded, but you can still see all your bounding boxes kind of and work on things that way. So just kind of a little tangent there to talk about what's going on with making an asset in this case. So all right, so this is all well and good, but there's some really cool stuff that we can do with this component geometry concept, with the idea of then variants within this. So instead of using this standard kind of component geometry setup here, I'm actually just going to, well, I'll leave it for right now. That's fine. So let's do component builder. And I have an HDA that I made for a little presentation thing. So I'm going to use that. And we're going to go inside this component geometry here. And I have this little can generator that I made. And this is going to help visualize this, I think, in a really nice way. So what I'm going to do is I'm just going to, actually, no, that probably won't work. So I'm going to click each of these. Each of these outputs is going to generate a can, or sorry, this HDA generates a bunch of different cans that I made. This was for a presentation I did over the weekend, but it's really useful for this too. So I'm going to use it. So what we can do here is it's got a whole bunch of different things. We can change height of the can. We can make it really short and squatty. Can make it really tall, all different things. We can turn the label on and off. It has ridges on it. You can change the number of ridges, blah, blah, blah. Super, super exciting HDA. But anyways, so here is what we have coming out of it, right? But what I made inside is a similar network to what we were doing before, where it has 3 different outputs on it, right? So we have our high res, we have a proxy here, which just takes away kind of the lip of the can and also the ridges on it, so it's a lower res. Then we have a sim proxy as well. I mean, it's pretty straightforward. It's all a can, so but can be helpful. So my can generator can do a bunch of other things. It can add in a rusty texture here. It can do a heavy rust texture there, that type of thing. And so what we are going to do here, got a bunch of different labels and things like that. So anyways, super fun stuff. But what we can do is we can use this to kind of build up our geometry. So what we're going to see here is just the proxy geometry, right? But what we can do instead is we'll do this with the... for this one, you could do the materials with Material X. I'll show you in a second. So these shaders are just, I originally was making it and was going to try to make it so all these shaders came in from this HDA. But again, because those files are saved in the HDA, they're the op lib definition. But you can do materials with either. I have a file that has all my shaders saved in it that I'm going to just grab and load in here. But I don't remember if they're Material X or not. Actually, I think they are. I think they are Material X now that I'm thinking of it. Let me see. I'll load them in and we'll take a look at it. But what I'm going to do is let's just make a couple different of these little setups here. So I'm going to grab that file, which actually is in my downloads now that I'm thinking of it. Oh, that's the wrong download. Sorry. Let me just grab this over here. For that other image there, I wasn't using any render engine yet. It was just OpenGL. And in fact, in this viewport, it's just been perspective. I'll use Karma while I'm showing this, but yeah, that's usually what I use. All right, so let me do this. Sorry, give me 1 second. I'm just going to move some files around. I really like granted, I work for side effects, so I'm a little biased, but I do really like the speed of the XPU, Karma XPU renderer. It's really nice, especially if you have like a good CPU and a good GPU. It can really crank. It's pretty nice. Anyways, so let's do this. So I have a shader file here. For production purposes. If you're doing in production, I would use in that case, I would use Karma CPU. It's more made for production. Hopefully sometime in the not too distant future, XPU will be ready for production as well. But I know a lot of studios are starting to implement Karma into their pipelines. So, or some are starting. I shouldn't say a lot, but studios are definitely starting to adopt it. So it's kind of cool. But in my past work, I used Arnold and Redshift for rendering. So, and a little bit of, if I needed real-time stuff, we would use Unreal. My brain stopped for a second there. Sorry. Okay. So anyways, we have a file here that I can bring in. So I'm going to sublayer in a file. This is kind of the base way of bringing in a file without really touching anything, doing anything to it. So I'm just going to load this in. I have some shaders here. And so here's my asset material. I made it the exact same way that this is set up here so that it's going to know where these shaders are and know kind of how to work with them. If it's in the same hierarchy, it's going to fit right into this component workflow. So there's that. Then we can come down here to this component material. That is not happy about something. Oh, right. Because yes, I have to set these up here so that it'll find the correct primitives. So what I'm going to do is I'm going to take the primitives that I want to copy these to. And in fact, what I want these to copy to is not just the shape, but I want to actually get the groups from this, right? Or the different elements from it. So let me just look and see how I separated these, what attribute I used. Shader, shot material path. So I think that's what I just promoted the shader up to use that way. So it just has a string for shader. So that's what I'm going to do. I'm going to partition it based on shader. So now I should have that in there, and I'm not going to prefix with the attribute name. I don't want that. So now when I look at these will match up 1-to-1 because it has the shader name in there. So cool. All right, that should be working properly. And so what I can do now is I can just apply these the way that I had them before. And so let's see here. Let me just grab both of these. We'll do aluminum first, and I'm just going to set aluminum there. And then here we're going to do this. And then tomato soup. Ah, yes, I know the problem. I don't have my textures in here. That was the issue. All right, for some reason that is not loading up. So, or that's not coming in. Oh. Yep, I did something real dumb. I'll give it a second to load this up. And we'll take a look at this here. Sorry about that. So here is the actual network that will work. It's doing the exact same thing, so there's nothing too exciting happening here. But let me just go back into my Solaris desktop. Sorry, it looks like I crashed this guy pretty nicely. Yeah, get out of there. Okay. Anyways, my bad. I don't know why that wasn't working because it's all I'm doing here, but I must have just set something up slightly differently here. That's working a little bit differently. So there we go. So there is one of them. There is a tuna fish can. Why this one says corn material, I'm not sure, but that's okay. So the one different thing I'm doing here is I'm using a little string in here to assign these materials using Vex. So a little shout out to the old Vex stuff we were doing before, but you can use Vex in here to assign your shader. So basically what it's doing is it's looking up the elements of these primitives in here. So if we look at our shape and we can look at these different prim vars that are in here, like our material path and shader and things like that. And so what it's doing is basically just looking up these two, the tomato soup and the rust aluminum, and assigning them based on that. So that's pretty much what it's doing and assigning it based on that. So it's a little bit different way of doing it, but it's slightly more advanced, but we'll just kind of look at the finished, pull the baked cake out of the oven and just look at this one. So what I'm doing here is basically setting up a few different shaders, right? So I've got this, we'll actually not call this corn material, we'll say tomato material. So there's our tomato soup can. We have a tuna can. So here in this one, I've set this up to be the heavy rust and tuna fish. So those are both coming out there. They're getting set their shaders are being set. Then we come up here and they get assigned here. And then this last one is a peas can. So just using the HDA inside of here with some separate parameters in order to build 3 different options, right? 3 different, variations on this can. So once you have that set up, what you want to do is put those into a component geometry variance node. And here what we can do is we can name this variance set. So here we could just say, I don't know, can options. We can just call it that, whatever. So that's going to be the name of these set of variations, right? So each object that's going into this component geometry variance node is going to be set as its own variant on our USD primitive. So now we can actually change which option we want at any point downstream once we save this out to disk. So this step right here turns each of these component geometries into an individual variant. And then this component output node is going to read it. Sorry, I'm going to turn that off, set default variance. So this is trying to load from disk, which it can't. So I'm just going to let this cook real quick. And then I am going to save this out to disk. Give it a second to kind of calculate everything. And I believe what it's actually doing for me as well is probably generating some thumbnails there. So now we're going to load it from disk, have it reload. And now this is actually a USD file on disk. If we come up here to our folder and go into USD, we can go into assets. Oh, sorry, this is in a different location, so I'm going to save. Well, that's okay. I can pull that up real quick. So okay, here's where it's saved. So limited soup cans. Here we are. So it saved out not only each of these USD files, but it also saved out all of the textures that we would want in there. So now all of our used textures are in this folder, which is really nice. So it's kind of making a little compartmentalized asset for us, right? We have all of our geometry in here. We have our shaders in here. We have the ability to unload them in the viewport, and we have our base asset here, this limited soup cans. And the reason I called it limited is because there's only so much that we can actually do with each of these individual variants like this, with using a component geometry in this way. So what we can do with this then, what are variants? What do they do? What are they good for, right? So I'm just going to throw a dome light in here just to kind of make it maybe a little more visual, or we can turn that off for now, actually. That's maybe actually a little too hard to see. But let's explore this variant. So we're going to click on Explore Variants and explore them this way. And the variant filter that we want is the one that we named here, which are can options. So we're just going to set that in there. And so now this is going to look at all 3 of those geometry variants, those 3 variants that we have inside of that USD file. It's saving this into a primitive called Explore Variants 1 because that's the destination prim right here, $OS. The source primitive, we're looking at the limited soup cans, and the variant set is can options. And we can adjust these as we'd want for, to space them apart, do whatever. So obviously if we have more variants in here, you will see a lot more options kind of come out of it. And then the really neat thing that we can do is we can stick this into an instancer, right? And we can instance these all over the place as, just a grid or whatever. In here, there's just a scatter on a grid, and we have a bunch of points in here. Oh, and the problem why they're all overlapping is because I have this explore variance set to explore and not duplicate. When I have it set to duplicate, that's literally just going to kind of put them all in the exact same place. You can't really totally tell, but they're all just in one spot. So then I'm feeding those into this instancer and kind of having those all propagate through like this. And so that's obviously one way that we could do this. Another thing that we could do is we could take out this explore variance, feed this right into the instancer, and our prototype primitive is just going to be the soup can. So we'll just do like that. And now we have all kind of the same soup can coming through. But because there's variance, what we can do is we could do a set variant at the end of it. And we can select some primitives. So I'll just select those in the viewport. So I'll just select it like this. Just draw it over like so, and then hit enter. And there we go. We've got our instances selected. So we've got a few instances selected in this viewport here. You can see each of these cans are getting their own instance, right? And then we can just come in here, grab our variant set, can options, and then we could just do those as, well, canned corn it's called, but it's actually tomato, but whatever. Not the end of the world. Not sure why it's saved that way, but that's fine. So we could change these variants, right? But this isn't the cleanest way of doing this, right? This is giving us only a couple options, and really we have a lot more options that we could possibly have in here. So let's look at maybe kind of the best way to think about working with this component builder in a way that we can create all these different variations for ourselves and kind of make it really flexible. And really, this is kind of, I think, the beauty of working with USD is you can create things that have a lot of flexibility in them and be able to create really interesting layouts with a fairly limited number of assets. So let's take a look at this here. So what I have going on here is I've created a couple different of these cans. So I created a tall one. Let me just home that. Then there's a mid-sized one here. We have a short one. And then we have one with no label that's just mid-sized, and it's got the ridges on it. We can see those. So what I'm going to do now is, instead of adding the shaders onto them, I'm just going to turn these into component geometry variants. So right here. So we're going to call this can geo, and we'll start with just the mid one. That'll be our working variant, I guess. So then over here, we're going to get our shaders just the same way we did before. And then we have component materials, just like we were using previously. But instead of assigning them, per geometry, we're just going to assign a one component material for each shader that we want to apply, basically, in this case. Or it could be sets of shaders, but I want to kind of separate them out quite a bit here. So the thing that we're going to notice is that up here we've got a material variant set that we can create. So I'm going to call this can material. So I'm going to create a couple different can materials. So this is going to be like a mildly rusty version, and then this is going to be like a nice clean prime version. Actually, I could call that clean. It's probably easier to think of it that way. So okay, there's a nice clean can, no rust. Then down here, we're going to change up a little bit. We're going to say label material. So these are can material. These are label material. So here I'm just applying this to the label. You can see right here that says label. So these are just groups now. We have can, label, and rim. So this is a little bit different than the way we were doing it previously with the shaders being called. This is we're just using the actual geometry group kind of from SOPs to assign the material. So here we have peas. So we're just going to assign the material path peas and kind of down the whole line here. So this is going to be the corn one, tuna fish, chicken soup, and tomato soup. Great. And so for each of these, the variant names are going to be the name of these nodes, right? So we have all of these four component geometries up here. Sorry. Those are going to be one variant set. These right here, these component materials that are called can material, are going to be a second variant set. And then the third variant set we're going to have is all of these labels. And so right here, we're going to just calling this flexible soup cans because they're very flexible in how they're made. And I'm just going to save this to disk. I'm going to go up one level here. We'll see that we have a flexible soup can that's being written. So it's just going through and calculating, it's making little thumbnails for the individual variants and things like that. So it's just doing that right there. So textures, Yep. And then there's all of our textures that are coming in as well. So, all right. So we've got our, yep, there's our thumbnail for it. If we were using that in a layout tool, which we're probably not going to talk about tonight, but just something to keep in mind. So, okay, so we have this saved to disk, right? So we're doing that same process that we did before, where we have kind of a master file, a payload file, and then a geo and a material file. This is like a base standard kind of way of working. And so here we're just going to bring that file back in from disk, just so that we know that we're reading it, kind of loading it clean in from disk. And we're not going to worry about this side of things here. I'm just going to get rid of those. Yeah, whatever. Okay, so we've got our cans, and I'm just going to instance those just the way I did before, right? So we've got all these different cans in here, right? However, what we can start to do is use these set variants in different ways than we might have used previously. So I'm not going to highlight this so you don't see what's going to happen here yet. But what we're going to do is we're going to look at all the primitives under the instanceable reference right here. Basically, all that means is that these are they're instanceable geometry. It's kind of like packed primitives when they're this optimized geometry that can live in memory very efficiently. Same kind of concept here. Instanceable references are basically like kind of the packed geometry of USD, more or less. It's a little different than that, but we'll just kind of say that as kind of an equal statement. So we're using these instances here. So we're reading all of the primitives. The first thing we're going to look at is the can geometry. If you remember, that's going to be whether or not these are going to be tall, mid-sized, short, or if they're going to have no label on them. Because in that case, we're removing a piece of geometry. So that's why it's also a geometry variant. We could set tall ones with no labels, short ones with no labels, all that stuff. But we're just kind of making this a little slightly simplified. So here in this, we're actually going to set a little expression. And what we can do is we can choose the variant by index. So because there are 3 variants on each of these, in fact, we can go to instanceable reference here and we can look at this. We're going to examine this so we can see where our variants are. So if we go just to instance 0 and look at our metadata, there's a lot of stuff in here. In fact, it tells you some really cool things like where the thumbnail are for them and the name of them, things like that. But if we scroll down, we'll see that there are 3 different variant sets, and we're looking at can geo. So there's 1, 2, 3, 4 in this. And so, and mid is the one that's set because we said that was going to be our working variant in all of this. So, so we've got these four variants that we want to work with, right? So what we're going to do in this set variant is say, we're going to randomize based on the primitive number, and we're just going to add a little seed number. I just added 12 in there. And then we're going to multiply that by num variants. And that's going to tell us the number of variants that are in this list here. And so we're going to make sure that that's an integer coming out of that too. So we're just casting that to an integer. So this is going to randomize for each instance that it goes over, or each of these instances in this instanceable reference primitive. So when we come down here, that's now going to change. It's going to change all of our geometry here. So some of these are going to be tall, some are going to be mid, some are going to be short, and some are going to have no label on them, right? So, So already I think that's pretty cool. Like we can already do some really interesting things with literally one node and setting up some variants on them. You can imagine this would work with trees, with buildings, with, all sorts of different things that would be in layout, kind of in your layout world, right? And that's really one of the things that Solaris is really, really good at, is doing layout, look dev, lighting, rendering, all that kind of stuff. So we've got all of those, but then obviously we can change like the label material too. So we're going to do the exact same thing, same setup, different seed number here for the label material. So now all of the labels are adjusted. And then down here, we're going to change the can materials. So this is going to go over all of those and change the can materials as well. Now we could technically do this all in one node because you can actually set the number of variants here. So you could set 3 of them and do them all in one node, which fine, we could do that. I just kind of like the idea of having them all spread out like this. And then if we add in a dome light and maybe turn on Karma here, we can see that we're going to get, this start to render. And there we go. We've got all of our different materials for our cans, rendered, shaded, all that kind of stuff. Yes, that is a great point, Matt. Thank you. So in fact, I did a talk on USD into Unreal for side effects at our one of our Hive events in November, and I did this similar kind of stuff with using USD and bringing it into Unreal. And so so all of these variants, that's part of the USD file. So thanks, Igor. Shift R to start Karma. I just slammed my knee into my desk. That felt wonderful. Thank you. That is a great shortcut. But so here are all of our different variants, all randomized, able to, be adjusted at any time. And these aren't just locked in now. They're still all live. We can still change all those variants whenever we want to. And like Matt mentioned, any DCC that supports bringing in USD kind of in its best form and within reason should support variants. That's a very basic part of working with USD. So whether you're doing, like he said, Katana, Clarice, Maya, within reason, he says. I haven't used Maya with it that much, or those other two, but definitely I've worked in Unreal, and it actually will bring in the preview shaders from Solaris, and that it builds out here. So it'll bring in the USD preview shaders in there. So that's kind of nice as well. And to I forget who had asked the question. Is Shift R gonna? There we go. Cool. That is a nice thing. I forget about that. Let's look at these shaders here because I am curious about this. Let me just do material. There's an edit material network. I should be able to see what this is. So let's see here. Let me look at one of these that's relatively interesting. Yeah, let's do this one. Material path, load. I think, yep. Yeah, these are Material X shaders. So this is my Material X network here inside of there. And it's, just few images coming in to a standard surface. And then this standard surface preview gets created automatically from the material network when you have this checked. So it'll auto-generate preview surface shaders. So if your material library has that checked, should be good. And so, so they're Material X shaders. So I can give it a shot. I don't know if it'll be angry that I'm streaming or not, but let's see here. So we'll come back down here. Let it load everything back up and randomize everything. I should have written it out to disk because unfortunately it has to do all that randomization again now because I kind of went back up. So it has to recook all that. I should have just saved it to disk and just read from there because then it would be ready to go at a moment's notice. Okay, so I should be able to do this. Let's do this. And I'm just going to go into the render settings. Here, it's D. We'll change it over to XPU, see if that works. Hopefully it should. Shouldn't give me any problems. There we go. Hopefully it won't trip up my GPU or anything. Still just initializing that, probably because it's in use a little bit right now. So it's much more responsive once everything has... I think it has to compile all the shaders, I think, is what it's doing. So there we go. Once optics starts going, you're good. So now it's much more responsive, nice and fast. And there you go. So so that is I think hopefully you start to understand a little bit of some of the power of working with USD, especially if you're creating many assets that are all going to kind of work together in unison like this, something like a can or a tree or, products that are going to go on a shelf. I'll actually be doing a full course on this like I said, that is going to go on the Side Effects website, and that's all based on making books. And so books on a shelf and lining them all up and everything like that. So, that should be hopefully coming out within the next month or so. But anyways, so hopefully this is all starting to make sense. I know we're kind of a little bit jumping around here, but trying to give some sort of an interesting introduction to this topic, but also see some, some really nice, something that's a little bit more visually appealing at the end of it, something that you can actually say, okay, I see what's going on here and why there's benefits here. So that's kind of, that was really what I had planned for today as far as, talking through different concepts and ideas and stuff in here. I think you can see that there's definitely some really technical things that are happening, within USD, within Solaris. In fact, if I, let me just do this real quick. Sorry. One more thing I wanted to show here. This is the same concept where we can unload these and we can see them all, in the scene like this. So that's kind of a nice thing to have and be able to, move around like that as well. So that is part of this concept as well. See, unloaded it and then it's fast. Then I should just written it to disk. So let me just show you that too, I guess, that if we sublayer this in from disk, it should not take as long to read everything in. Let's just see here, sublayer. So I'm just going to load this back in from disk. That's a sublayer. And oh, right. Sorry. I need to save this. So this is this can scatter layout. I'm just going to save that to disk. Yeah, so I think that USD really shines, to answer your question, it really shines when you're working with either with layout and you're building maybe, a larger scene, scattering things around in your scene. Now, in this case, I'm just doing a simple grid. I'm not really doing anything overly interesting with these elements. But if you're doing a large scene, trying to scatter things, place things quickly in your scene, I think that's where USD really shines. It gives you flexibility as far as with multiple shaders on one asset that you can load in, like in this case. These are all still live, obviously. So we've got all these shaders here, and I can do another set variant here, and I can still choose in the viewport here. I can just select some of these, and I could, set, oops, that's weird. Why did that not? Yes. There we go. We could just change the label and, whatever, do tomato soup for all those. Right. So I think there's kind of two different worlds, right? Which USD really shines in. It's the collaboration side of things where you can have different departments working on different files and different, sections of the scene. It's all non-destructive too, right? So this kind of works like Photoshop in a sense, where you can layer things on top of each other. Right now, we're just looking at individual files on disks that are loading and unloading, but you can actually load things on top of each other, and they'll start to kind of layer and compose together to make your scene. So you could have multiple, files that are coming from each of the different departments, or, even if you're working with multiple people, have each of those files saved out to disk, and then when something happens upstream, it flows down through the USD software and is composed to whoever's looking at it at whatever point they're inspecting it. So that's the one really good way that USD shines. And I think it also, like I said, for scene layout, things like that, and then look dev and lighting. Igor, I think I'd heard you mention that you are using that for using it to do look dev and things like that, taking all your stuff and dropping it in. But I think really if you're doing anything beyond just basic lighting and shading in Solaris, I think you can really start to benefit from some of the optimizations and things like that USD brings. And of course, if you're going to share it with someone else and want to share all those features, USD allows you to do that super, super easily. So there's so many different kind of ways that USD is becoming more and more a part of, file transfers and, working in different departments. I think there's a lot. There's kind of this multi kind of interesting. Yes, I'm reading what you're saying here, Matt. So Matt says, for me, it's bringing SOP thinking to high-level scene manipulation. The object level is brittle. It's not reactive to changes. LOPS lets you bring Houdini smugness to higher level operations. Yes, the scene graph tree is really useful to check your hierarchy. Yes, exactly. You can see kind of the visualization of almost that path attribute that we were looking at, right? So it's kind of an interesting thing to see the hierarchy there. So yeah, it is a way to almost see your hierarchy of your different geometries and things like that. So it is an interesting thing to see. It's a little bit different from, a lot of these concepts are different from, maybe some of the traditional ways of thinking about working in Houdini. And a lot of people will be frustrated with that, right? Because there's some things that we have to not unlearn, but just change the way that we're viewing them when it comes to working in USD. The guys that I've talked to on the side effects side of things that are like, have come from production or whatever, they have a lot of different, views on why this stuff is good. And if it's new to you, it's going to feel like you're doing something that doesn't feel natural, maybe doesn't make a ton of sense. But I think there's a lot of benefits that come once you start to understand kind of the way in which it works. There's also some quirkiness to USD too. I mean, it's created by Pixar. It has a lot of their legacy to how their studio works baked into it. So some of those things are abnormal to people that haven't worked in a studio environment like that, I think personally. But another really great thing if you want to look into how studios are using USD, now that you've started to understand some of how this works and how some of how to look at things in the scene graph tree and set variants and things like that, is looking at the Animal Logic A Lab. That's a great resource to kind of look at how a larger scene is built if you want to take a look at it. And it's something that you can load on a pretty reasonable computer. I know some people have tried to load like the Moana scene from Moana or whatever, and that thing is like crazy hard to load. Like there's a whole bunch, like it just is not built in a way that's easily opened on a normal desktop computer. But the A Lab, I've opened it before. It's not like super performative, but it definitely is. You're able to kind of poke and prod at it and see what makes it tick. So that's a really nice example to take a look at if you're interested in looking at how studios are using USD in film production pipelines. So yeah, well, hopefully this gives you kind of a starting point into USD. This certainly has talked about some really simple things and some maybe more complicated things all in one. But like I said, I wanted to get us to a place where we could at least look at something interesting and not just have this high level conversation. But hopefully this is something that is valuable. I'm gonna kind of keep going over the next few streams here and talk a little bit more about maybe USD on different in different ways and different ways of kind of working with it and using it, what's going on, maybe even a little bit under the hood too, to kind of see how that's working. Maybe we'll crack open a couple of the files and there's a huge Moana scene. Good luck downloading it. It's gigantic. I'll try to explode my PC. Good luck. Yeah, it's definitely a headache inducing one. Yeah, you guys are welcome. Well, hopefully you guys can join again. I'm planning to stream a little bit differently just because I got off last week, but I'm going to do Thursday this week just to kind of give myself a couple days off break, and then we'll talk some more USD on Thursday and continue there. So yeah, if you guys are interested in joining the Discord server, if you want to have more extensive conversations. I know there was a couple questions that came up that I was kind of like, might need a little bit more in-depth offline conversation. Please go to Houdini Hangout. You can join the Discord server there. There's an invite link, and also the schedule is there as well. So that'll show the next few times that I'm planning to stream. I am also going to be taking off for a few weeks to go on vacation at the end of this month. So I will be MIA for a while. So, hopefully everybody will play nice on the Discord. I might maybe read that for entertainment here and there if I have Wi-Fi. But so I'll be a little MIA at the end of the month. But for now, I guess I'll just sign off there and say thank you guys so much for joining, for contributing to the conversation, and giving your opinions and thoughts and all that kind of stuff. It's always really great to be able to have these conversations, and it's just a lot of fun. So thank you guys so much for joining tonight, and hope to see you Thursday. I'll talk to you guys later. Bye.